Welcome to Section 5.5, proving that figures are special quadrilaterals. Our objective is to prove that quadrilaterals are rectangles, kites, rhombuses, squares, and isosceles trapezoids. Our homework is going to be on page 259 to 262, 4 to 7, 13 to 16, and 23. As this video progresses, please make sure that you pause and write down all the important information. First, there are three ways to prove a rectangle. First, if we know it's a parallelogram, and we know that it contains at least one right angle, then it's a rectangle. Secondly, if the diagonals of a parallelogram, so again, we know it's a parallelogram, are congruent, then it's a rectangle. And last but not least, if all four angles of a quadrilateral are right angles, then it's a rectangle. The first two require knowledge that the quadrilateral is a parallelogram. The second one does not. All we have to know is that it has four sides. There are two ways to prove a kite. Number one, if two disjoint consecutive sides of a quadrilateral are congruent, then it's a kite. And secondly, if one of the diagonals of a quadrilateral is the perpendicular bisector of the other diagonal, then the quadrilateral is a kite. There are three ways to prove a rhombus. Number one, if a parallelogram contains a pair of consecutive sides congruent, then it is a rhombus. So again, we have to know a parallelogram to start. Number two, if either diagonal of a parallelogram bisects two angles of the parallelogram, then it is a rhombus. And three, if the diagonals of a quadrilateral are perpendicular bisectors of each other, then it's a rhombus. Again, just like we had for the rectangle, for 1 and 2, we needed to know that the quadrilateral was a parallelogram, but for the third one, all we needed to know was that it has four sides. There are three ways to prove an isosceles trapezoid. Number one, if the non-parallel sides of a trapezoid are congruent, then it is an isosceles trapezoid. Number two, if the lower or upper base angles of a trapezoid are congruent, then it's an isosceles trapezoid. And number three, if the diagonals of a trapezoid are congruent, then it is an isosceles trapezoid. For all three of these, we have to know it's a trapezoid before we can say it's an isosceles trapezoid. Last but not least, there is one way to prove a square. If a quadrilateral is both a rhombus and a rectangle, then it's a square. Squares are sometimes the most difficult ones to prove. You have to prove first that it's a rhombus and it's a rectangle before saying that it's a square. Okay, so for our last part of this, here's our homework answers. The thing I usually use to write with is malfunctioning, so I'm not able to actually do any examples with you. I do apologize for that. I'll make sure that tomorrow we do the examples in class. But make sure you have written down all those properties, so if you need to, go back and pause it, and make sure you really understand what properties make each special type of parallelogram. Here's the answers for the homework, and I'll make sure tomorrow in class we actually go through those examples. Have a good one.